Hello, Algebra 3. This is our video key for section 7.1. That was our lesson where we were solving logarithmic equations. So let's get going with question number 1. In question number 1, we're given log base 13 of negative 4v minus 2 is equal to log base 13 of negative 5 minus 3. So we check each side of the equation. If we have a log of the same base, which we do, we have log base 13 on the left and the right, we can set equal whatever we got going on here equal to what we got going on the right side there. So we will have negative 4v minus 2 equals negative 5v minus 3. So in order to solve this, I'm going to set it equal to v, so I'm going to add 5v to each side. I'll get v minus 2 equals negative 3. I will add 2 to each side, and I get v equals negative 1. So this is a possible solution, but I need to check it, make sure it's not an extraneous solution, that it is in fact a valid solution. So I'm going to plug negative 1 into my first set of parentheses here. I will get negative 4 times negative 1 minus 2. Negative 4 times negative 1 is 4. 4 minus 2 is in fact 2, so that's positive. So we're good on the left side here. Let's go ahead and plug it in on the right side. Excuse me, on the right side over here. I'll get negative 5 times negative 1 minus 3. Otherwise, I get 5 minus 3, which is equal to 2, which is positive. So we're good on the right side. So v equals negative 1 is a valid solution for number 1. Number 2, we have log base 12 of negative 4n equals log base 12 of negative n. So since I have a log of the same base on the left and right, I can set equal negative 4n and negative n. So if I want to solve this for n, I will add n to both sides. I'll get negative 3 equals 0, or n is just going to equal 0 in this case. So is this a valid solution or is it an extraneous solution? I need to plug it back in here and see. If I plug it back in here, I'm going to get log base 12 of 0, which I cannot have. And if I plug it in over here, I get log base 12 of 0. So I can, when I plug this solution back into my log, I cannot have 0 or a negative number. So in this case, this is not a valid solution, and my answer to number 2 is no solution. Number 3, I have log base 15 of 9 equals log base 15 of 7 minus x. Since I have a log of the same base on the left and the right, I can set 9 equal to 7 minus x. I'm going to solve this for x, so if I add x to both sides, I get x equals negative 2. So I'm going to plug those back in. Well, I have a positive number here, so I'm good on this one. If I plug in a negative 2 over here, I get 7 minus a negative 2. That's also a positive 9, so I'm good with this. X equals negative 2 is a valid solution for number 3. Number 4, log base 19, negative n minus 7 equals log base 19 of 10. Since I have a log of equal bases on both sides, I can set negative n minus 7 equal to 10. I want to solve for n, so I'm going to get negative n equals 17, or n equals a negative 17. So I have to plug these in here. So if I plug negative 17 in here, I'll get 17 minus 7, so that's a positive 10. I'm good. 10 is always going to be positive over here. So negative 17 is a valid solution for number 4. Okay, and number 5, I'm given log base 4 of negative 4b equals log base 4 of negative 3b plus 9. I have logs of equal bases on both sides, so I can set negative 4b equal to negative 3b plus 9. Adding a 3b to each side, I get negative b equals 9, or b will equal negative 9. So let's plug this back in to make sure this is a valid solution, not an extraneous solution. Negative 4 times negative 9 is positive 36. I'm good on my left side. Negative 9 in here, that's going to be positive 27 plus 9. That's a positive number as well. So b equals negative 9 is a valid solution for number 5. Number 6, I have log base 7 of negative 3p equals a log base 7 of negative 4p plus 10. I have a log of equal bases on the left and the right, so I can set equal negative 3p and negative 4p plus 10. I want to solve this for p, so I'm going to add 4p to each side. I'm going to get p equals 10. So is this a valid solution? I don't know, we have to plug this back in. I will, if I plug p in here, I get a negative 30. That's no good, can't have a negative number. If I plug 10 over here, negative 40 plus 10, also a negative number. So p equals 10 is an extraneous solution. And for number 6, we have no solution. Number 7, we have log base 8 of x minus log base 8 of x plus 2 equals 2. So this is a little different than our first 6 problems we had in this assignment. The first 6 problems we had a log equals a log. But here we're going to have log equals a number. So if we remember the steps in this type of problem, the first thing we do is we condense what we have going on our left side here into one single logarithm. So we have to use one of our logarithm properties. I can tell by looking at this, since I have a subtraction sign in the middle here, I'm going to be using the quotient property. After I condense this into one logarithm on the left side, I'm going to rewrite it into exponential form and then solve for the variable. So let's go ahead and rewrite this. I'm going to have log base 8 of x over x plus 2. And that equals 2. So I just use my quotient property there. Now I'm going to rewrite this into exponential form. So I'm going to have my base 8, my exponent of 2, and that's going to equal x over x plus 2. 8 squared is 64, so 64 equals x over x plus 2. So from here, it's just basic algebra. So to get this x plus 2 out of the denominator, I'm going to multiply both sides by x plus 2. I'm going to get 64x plus 128 equals x. Let's go ahead and subtract. Let's see, I'm going to get 63x equals negative 128. And so finally, I'm going to get x equals negative 128 over 63. Is that a valid solution? I don't know. We have to check for see if it's an extraneous solution or not by plugging it back into our original log. So if we plug it back in up here, well, we get a negative number. We cannot have a 0 or a negative number for a log. If we plug it in over here, negative 128 plus 63, we are also going to get a negative number, so we are not good there. So this is not a valid solution, as in fact an extraneous solution. So for number 7, we get no solution. Number 8, we have the log base 3 of x plus 5 minus the log base 3 of 6, and that's going to equal 1. So we can see we're going to have log equals a number, which means we're going to have to condense. Our first step is to condense what we got going on the left side. I have a subtraction problem here, so I know I'm going to use my quotient property. So let me rewrite that, condense that into one logarithm. I'm going to get log base 3 of x plus 5 over 6, and that's going to be equal to 1. Now I'm going to rewrite this in exponential form. So my base is 3, my exponent is 1, and that's going to be equal to x plus 5 over 6. I'm going to multiply each side by 6 to get that 6 out of the denominator. 3 to the first power is just 3 times 6, that's 18. 18 is going to equal x plus 5, or x is going to equal 13. I have to make sure this is a valid solution, not an extraneous solution, so I'm going to go back and plug it into my original equation. 13 plus 5 is 18, that's positive. So we're good on this one. And log base 3 of 6, that's always going to be positive, so we're good on that one. X equals 13 is therefore a valid solution, and our answer for number 8. Here's number 9. We have log base 8 of x plus log base 8 of x plus 2 equals 1. So our logarithm equation is equal to a number, so we're going to have to, first of all, condense our left side into one logarithm. I have a plus sign here, which means I'm going to use the product property. So I'm going to end up with the log base 8 of x times x plus 2, and that will equal 1. I'm going to rewrite this as a exponential. Go equation. So I'm going to get 8 to the first power equals, I'm going to go ahead and distribute that x through. We get x squared plus 2x. I'm going to set this equal to 0 and see if I can't factor it. So I'm going to get x squared plus 2x minus 8 equals 0. But I can indeed factor it. I will get x plus 4 and x minus 2 equals 0, because 4 times negative 2 does equal negative 8. 4 plus negative 2 does equal positive 2. So my answers are x equals negative 4 and x equals 2. So now I have to check to see if these are both valid solutions or if they are extraneous solutions. So let's plug our negative 4 in here. If I plug negative 4 in here, I get a negative number in this logarithm. I also get a negative number in this logarithm. So negative 4 is an extraneous solution. If I plug 2 in, I'm going to have a positive 2 here. I'll have a positive 4 here. So x equals 2 is a valid solution. So negative 4 is extraneous, 2 is valid. So our answer for number 9 is x equals 2. Here's number 10. We have log base 9 of x plus log base 9 of x plus 4. That's going to equal log base 9 of 5. So I have log equals a log, but I do have to condense what I got going on my left side here into one logarithm. I have a plus sign in the middle, which means I'm going to use that product property. So when I condense, I will get log base 9 of x times x plus 4. That's going to equal log base 9 of 5. So now that I have a single logarithm equals a single logarithm, and they're both at the same base, I can set equal x times x plus 4 equals 5. I'm going to go ahead and distribute that x through. I'll get x squared plus 4x equals 5. I'm going to set this equal to 0 and see if I can't factor this. So x squared plus 4x minus 5 equals 0. And can I factor this? Yes. I will get x plus 5, x minus 1 equals 0. 5 times negative 1 is negative 5. Positive 5 plus a negative 1 does give me a positive 4. So that's the correct factorization there. So I'm going to have x equals negative 5 or x equals 1. Now I have to check and make sure that these are valid solutions and not extraneous solutions by plugging them back in to my original equation. Well, I don't have to worry about this over here. 5 is always going to be positive. If I plug a negative 5 in here, that's a negative. If I plug a negative 5 in here, that's a negative. X equals negative 5, therefore is not a valid solution. It is an extraneous solution. How about if I plug 1 in? Plug 1 in here, I'm positive. I plug 1 in here, I'm positive. So I am good on x equals 1. So negative 5 is an extraneous solution. 1 is a valid solution. So our answer for number 10 is x equals 1.